Hey guys and gals, welcome to our new normal. This is Miss Griffith. I'm coming to you with some notes today. Hopefully our notes don't take very long and the homework shouldn't take very long either. Our max amount hopefully is about 30 minutes per day. That's our goal, so that's what we'll hopefully stick to. I welcome any feedback that you have here. So hopefully what you've done is you've copied these notes into your notebook so you can just kind of follow along as you put it in your notebook. That would maybe be the best thought here, but we'll play it by ear and we'll kind of keep developing as we go. So this is page 16. Remember, this is a whole new unit, page 16. We're starting with gas pressures, and this is the one we're doing for 3:30. All right, which is next Monday. Okay, so getting going here. We've got gas pressures. We're going to start with some properties of gases, but I thought we'd jump in by reviewing the types of matter. So our first type of matter is a solid. Our definition of a solid is one that has a definite shape and volume. So remember, it's something that has a definite shape and volume, so it doesn't change. So if I draw a particulate diagram, remember that's like just our favorite shape. So we've got some circles. They're taking their own shape. They don't take the shape of the container, and so on. All right, rolling down. We have our liquids. Our liquids definition is that they have a definite volume, but not a definite shape. So we have a definite volume, but not shape. So we know that the shape will change. It'll take the shape of a container. So if we go with our next favorite shape that's maybe like a triangle or something, and we put our triangles here on the bottom, they're kind of taking the shape of the container. Last but not least, the one we're going to be focusing on here is our gases. Our definition of a gas is one that has no definite shape, no definite volume, or definite volume. So it takes the shape of the container, it bounces around, it spreads all out. So we'll put those as squares, just kind of intermingled throughout this room, this particulate diagram. So that's kind of a quick review on solids, liquids, and gases. Now we're going to jump into the definition of pressure. And pressure's official definition, make this a little smaller so maybe I can write a little bigger or better, is force per unit area. Force per unit area. So force per unit area, this is how much force is exerted per unit area. So our label would be, like if we're thinking about our pressure that we measure in our car tires, that's in pounds per square inch, which is pretty handy and easy. All right, so as we move on, the units of pressure, we actually have quite a few tons of these, or quite a few of these units of pressure, and most of them are on the back of your periodic table, so hopefully you still have access to that and can find those on the back of your periodic table. They're all listed on there except for, I think this Tor one is the only one that's missing off of the back of there. So you have all these conversions. You can add it on the back of your periodic table if it'll help you. That'd be something that you would want to do. All right, awesome. So we're just going to work to convert these. That's all the work we're going to do today. So this is just going to be like unit canceling. So what we've got is that first one, we're going 730 mmHg, and we're taking that to PSI. So if we slide this over a little bit, we see what we're going to do is we're going to set up a T-chart, 730 mmHg. We're going to put that on the top of our T-chart, just like we've been doing T-charts all along. This is what we're given. All right. Put a little X down there on the bottom. And where we're going is what we're going to put on top. This is just like in our stoichiometry that we just finished a while back now. But we've got 14.7 psi. That's from right here, 14.7 psi. And on bottom, we're going to put that 760 mmHg. And then we're just ready to calculate. And this is just like normal calculations with our T-charts. We're going to take 730 times 14.7. And then we're going to divide by 760, hit our equal sign, and that will give us our answer. So typing this into my calculator, 730 times 14.7 and then we're going to divide by 760. We should get 14 point, well, actually with that, it's 14.1197, but then we got just 14 is our answer there, and it's in PSI. The reason we kept 2 was because our answer only had 2, or our initial problem only had 2. So 14 PSI. Make sense? Awesome. Let's try one last one. I'm going to change color here so we can see what we're going to. So we'll go purple here. So we've got 0.888 bar, and we're taking that to torr. So again, we'll put the bar on the very top left of our T-chart. Then we're going to put on the bottom, we find what it is equal to in bar. So we're going to put 1.013 bar on the bottom. And on top, we're going to put torr, which is that 760 up here, 760 torr on top. And so to type it in, we're going to take 0.888 times 760 and then divide by 1.013, and that will give us our answer. So let's plug that in. And we're going to get 666, and that's torr. All right, that's our lesson for today. There is homework posted on Canvas. Please work through that, but it's going to be all similar to these unit conversions or these pressure conversions that we just did. Have a great day.